Hi, good evening. So, why we are having this class? This is the first class for organic chemistry. As you know, then this is parallel to our physical class. We are doing the physical classes at Faraday, Candy, and Colombo. Since we completed inorganic chemistry, since we completed Unit 11, even chemical kinetic, then we decided to start organic chemistry. This is how we started. This is the first day. And not only organic chemistry, at the end of this week, this month, actually, I'm going to start even Unit 12 also, equilibrium. That is the biggest unit-wise. If you consider whole syllabus and if you consider it unit-wise, equilibrium is the biggest unit. We will start that one at the end of this month also. Okay, right. Then if you can see me, I mean, if you have some problem regarding the video and audio, any lagging problem, better or any doubt you have regarding this class, then better you put a message in the chat box in the YouTube, right? In YouTube, you can send your any doubts or anything regarding this class through the chat. And next thing is, then there is no person here to control the chat box. In YouTube lives, then there are something can happen in the class. So if you see that some kind of inappropriate chats, just ignore them. If I see them, actually, definitely I will remove them. But right, you can just ignore it. Ne? Can you hear me and see me clearly? Yes, put yes or no. I hope you can see me and hear me. Ne? You can put yes or no in the chat. Yes, good. So far, no problem. Okay. Okay, let's then continue this. So once we consider organic chemistry, you know that covers then 4 units. Unit 7, 8, 9, 10. Is this important? Of course, it is important. In the case of organic chemistry, that will give about 23 marks. We can't say exactly it's 23. Sometimes it's 22, sometimes it's 24, sometimes it's 25, sometimes it is 21. It depends from one year to the other. Generally, we can say some around 23 average. Each and every year, you get 23 marks out of 100 for organic chemistry part. Therefore, this is very, very important. Then if you are looking for A for chemistry or B for chemistry or even C, you can't then skip organic chemistry part, right? So if you are looking for then S pass only, if you think that, okay, S pass is enough, then maybe you can then just ignore organic chemistry part. Otherwise, definitely you should select organic and you have to be good in organic chemistry. This is kind of, then once you consider organic chemistry, we have memorizing part is there definitely, and there is logical thinking part also. Maths application is very, very less here. This is quite different from the inorganic chemistry part. Inorganic chemistry, the majority is then just memorizing, but in organic chemistry, it's not something like that. Okay, right. Then what is organic chemistry? So if someone asks what is organic chemistry, I will answer it in this manner. Let's go to first chemistry. So if someone asks what is chemistry, I know definitely you have that famous answer. What is that? Chemistry is about the matter and the changes it undergoes. That is your famous answer. Yes, it is correct. Chemistry is about matter, right? Then someone can ask, what is matter? Again, you have that famous answer. Matter is anything which occupies a space and has a mass. Again, it is correct. So generally we can say matter is everything around us except the form of energy. Everything around us, we can consider it as then matter. But do you know this matter can be classified chemically into two parts? What are the two parts? Chemically, I'm talking about chemical classification, not physical. Element. We can find matter in element, and we can find matter as compounds, elements and compounds. That's how we can classify matter into two parts chemically. Then why I got these things, that is to give you some proper introduction for organic chemistry. So, then in day-to-day life, we use those matter. I told you, everything around us matter. So then give me some examples. As example, I take this one, water sample. If I put water out among these two, which one is the proper place for water? We know it is definitely compound. I'm not going to explain these classification and everything because today our target is to get but introduction for organic and completing nomenclature for organic compounds. That's what we are going to do today. So here you have done this one, water. It's a compound because compound is something which consists of more than one element. If you consider copper wire, you have seen that one, that pink brown color copper. It's an element. All of these things, we can find these things in around us. Oxygen gas we inhale, that is placed under element, because oxygen element that cannot be further divided by chemical means, that cannot be further divided into simple forms by chemical means. Therefore, this is also identified as an element. Next, consider the natural gas. Natural gas is a mixture of gases. One gas I can give methane gas, CH4. That's also compound. Next, when you consider then vinegar available in your kitchen, it is also a compound. I mean, it's a mixture of compounds. If I take one component, the main component is acetic acid, CH3COOH. That's also a matter and it is a compound. Let's go to your kitchen and talk about this one, LPG gas. Once you consider LPG gas cylinder, what does it contain? Those are liquid petroleum gases. Two chemical compounds available. One is this one. Don't worry if you find difficulty to understand these structures. We will talk about that one today. This is butane. There is another compound available in your LPG gas cylinder. It's propane. These are compounds and those are matters. Got it? So likewise, if I go to baking powder, baking soda, then it's sodium hydrogen carbonate. So likewise, I can list out then thousands of compounds you use in your day-to-day life. So once you consider these compounds, I underline these examples. I underline this one, this one, this one, and this one. Now I think you can understand the importance of these compounds. These compounds mainly contain carbon element. Understand? So therefore, if someone asks what is organic chemistry, you need to first understand or identify what is organic compound. Simply organic compound is what? Carbon containing compounds. These are examples. Methane is carbon containing compound. Acetic acid, carbon containing compound. Propane, butane, carbon containing compound. Then someone can ask, okay, wait, sodium bicarbonate, sodium hydrogen carbonate, carbon is there. Isn't that organic compound? No, we don't consider that one as an organic compound. Right? So generally we say carbon containing compounds are organic compounds. So the chemistry about these carbon containing compounds is known as what? Organic chemistry. So that is organic chemistry simply. The properties, reactions, uses, applications of these compounds will be discussed under organic chemistry. So in this case, remember then, I assume you know nothing about organic chemistry. I assume your knowledge is zero. Based on that level, I will develop the lesson, right? So maybe some of you know about these things, then it's okay, because I assume you know nothing. Based on that, I develop this lesson. Correct? Then, in our syllabus, then I told you there are only 4 units under organic chemistry, but it is just the basic. Organic chemistry part is a huge part in chemistry. You can continue this organic chemistry in your A level. Thereafter, you can go to the university. If you go to the Faculty of Science, you can continue chemistry as a main subject. Then you can select organic chemistry and learn organic chemistry under your degree program. You can be specialized in chemistry. Then you can apply for PhDs. And the PhD also, you can continue organic chemistry. So it's a huge part. Then I was fortunate enough to actually understand or learn these concepts under the supervision of world famous scientists, professors, senior professors in my degree program. I got my degree from University of Peradeniya, Faculty of Science. I did chemistry as a main subject. I selected chemistry as a main subject. So under that chemistry department, there were recognized senior professors, and I was fortunate enough to learn these concepts, these advanced chemistry under their supervision, right? So likewise then, you can continue organic chemistry in your entire life. But what we do in A level, we just touch the basic and try to understand the basic. Therefore, it is very easy. It's not difficult. It is very easy part. So all of you can understand. But important thing is, you need some basic knowledge to understand these concepts. As example, Unit 1. I hope you are good in Unit 1. In that case, write in electron configuration, and last part, the trends shown by S and P block elements, atomic radius, ionization energy, electron gain energy, electronegativity. You need those parts. Then from the Unit 2, you should know how to draw the structures, how to draw Lewis structure, how to predict the hybridization, how to compare the electronegativity of different atoms, or how to compare electronegativity of atoms of same element. Those things you need. So if you have these basic things, actually, it is enough to understand the organic chemistry properly. I hope you got the introduction, simple introduction for organic chemistry. Right, here I have given actually the note also. I hope you collected that one. It is available in the description. And you can simply download that one and then refer it. If I share this one, wait a minute, let's see whether I have it. Yes, I have it. So this is the PDF version of the tute. As you can see, the introduction part is given. It's printed part. No need to write anything. You can just go through this and try understand it. Thereafter, there are some spaces available here. These spaces should be filled within this class. Okay. These spaces should be filled within this class. Maybe some of you don't have the tute now. It's okay. It's completely okay. You can just once I share that one in Zoom, it's not available in YouTube, no? That's a problem. Okay. I shared the PDF version, but when I share in Zoom, I think it doesn't appear in YouTube. This is the first time. This is the first time I'm doing live classes. I heard some unnecessary things. Yes. So as I told you, then this is the first time I'm doing this live classes. Therefore, if you find some difficulties, just please excuse me, right? Some technical issues and problems there may be. Just excuse. Okay. Now you know what is organic chemistry. It's simple. It's the study about carbon-containing compounds. But we have this problem now. Why this carbon element form this number of compounds? I mean, there are a huge number of compounds available. There are 118 elements. Among these 118 elements, why only carbon? There are some special things here. What are the special things regarding this carbon? There are several reasons. First thing is, you know, the valency of carbon is 4. That's a reason, one reason, not just one and only. There are some more reasons, but first reason we can say the valency of carbon is 4. What's the meaning of that? At the same time, carbon can make 4 bonds with 4 different atoms. Carbon can make 4 bonds with 4 different groups of atoms. That is the reason. As example, if I say carbon make 4 bonds with hydrogen, you know the compound, it's methane, CH4. But if carbon make 3 bonds with hydrogen and 1 bond with chlorine, what's that? Methyl chloride. We'll come to that later. If 3 bonds are filled with then chlorine and 1 bond filled with hydrogen, it's chloroform. You have heard about this, chloroform. Okay, so therefore, since it can make 4 bonds, there are different combinations that it can combine with different atoms and the group of atoms. According to that, you see large number of compounds there. That's one reason. Second reason, catenation power of carbon is very high. I don't know whether you have heard about this term actually, catenation power. Some of you have heard, ne? Those who are in my class actually definitely you have heard about this. Catenation power means simply ability to self-linking ability to make a branch chain, straight chain or branch chain, and even ring structures like this. If you don't understand this, I mean, some confusion available, then it's okay. But in inorganic chemistry, under the chemistry of carbon, I explained this one. So catenation power of carbon is quite high. The reason for that one is CZ bond is very strong. Since the carbon-carbon bond is very strong, it has ability to make another bond with another carbon atom, make another bond with another carbon atom. As a result of that, it can make then straight chain, branched chain, and even ring structures also. This is another reason why carbon makes large number of compounds. Third reason, not only single bond, carbon can make double bond and triple bond. Ability to make multiple bond is another reason why we get large number of organic compound, carbon containing compound. And these bonds are very stable bonds. Another reason to have a large number of organic compounds, carbon containing compound, is this carbon can make very stable bonds with other elements like hydrogen, oxygen, halogen, what else? Nitrogen, sulfur. So carbon has ability to make a very stable bonds with other elements like hydrogen, oxygen, halogen, nitrogen, sulfur. That's another reason to have large number of carbon containing compounds. Another, I can say carbon is relatively small atom. Where do you find carbon in periodic table? In the periodic table, you find carbon atom in the second period. So second period, the second period atom means simply small atom. Small atom means it can form a very stable covalent bonds with the other elements. So likewise then, carbon has several properties which are responsible for making large number of carbon containing compounds. Then when you consider another element, like among 118, there are some other elements. So if you consider some other element, maybe those elements can have this property or this property, not all these things at one place. So carbon has all these properties within itself. So that is why it can make large number of compounds, and we take all these compounds into one family, and thereafter we talk about the chemistry of that. This is known as then what? Organic chemistry. So then I think in the printed note, I told you under page 1 and 2, there is a certain space that is to completed. I mean, this note should be written. But other than that, yeah, thereafter I will show you some different ways to draw the structure of carbon containing compound also. But before that, let's write this one. I hope some of you have the note, but if you don't have the note, it's completely okay. You can simply have a piece of paper and then write the topic organic chemistry and then write the note. Later, you can get the printout. Thereafter, you can simply transfer that note to the printed note. That is the way you can complete it. Harry. We are here. I mean, now actually I can't share the note. Although I share it, actually nothing will appear in YouTube. So therefore I don't share anything, and then simply continue this one. Start the note like this. I hope you can hear me. If you can't hear me, then you can't continue the note properly, but I think you can hear me. Anyone has any difficulty to hear me, then just put the message in the chat. Write it like this. Start a new point and write it. Carbon can form large number of compounds. Carbon can form a large number of compounds due to several reasons. Carbon can make large number of compounds due to several reasons. Some of them are given below. Some of them are given below. Some of them are given below. Okay, let's write them one by one. Write them one by one. First one. Valency of carbon is 4. Valency of carbon is 4. This can make 4 different bonds with. This can make 4 different bonds with 4 different atoms or group of atoms. This can make 4 different bonds with 4 different atoms or group of atoms at the same time. At the same time. When I explained, I showed that if they make bonds with different atoms, that means you have new compounds. No need to write them. Just I explained that one. Let's go to second property. Second property. Carbon has very high catenation power. Carbon has very high catenation power. Just continue that one. Due to this ability, carbon can make bonds. Carbon can make bonds with several other carbon atoms to form straight chain, branched chain, and ring structures. Straight chain, branched chain, and ring structures. This ability is due to stable CC bond, carbon-carbon bond. This ability is due to a stable CC bond. These are some examples for straight chain, branch chain, and ring structures. Here, the valency of carbon not satisfied. You know, valency of carbon should be then definitely 4. But here, I just show you only the chain. Other atoms are missing here. We will come to these things later. Therefore, no need to draw anything here, just to have that picture, right? Straight chain, branch chain, and ring structures. These are possible. Right, let's move to third reason. Write the third reason like this. Other than single bonds, carbon can make multiple bonds. Carbon can make multiple bonds with another carbon atom. Other than single bond, carbon can make multiple bonds with other carbon atoms. Within bracket, better you copy this one. These are the multiple bonds, CC double bond and CC triple bond. Right, let's jump to fourth one. Write the fourth one like this. Carbon can make strong bonds with hydrogen, oxygen, halogen, nitrogen, sulfur, etc. Carbon can make strong bonds with hydrogen, oxygen, halogen, nitrogen, and sulfur, etc. Write the fifth reason. Write the fifth one. Since carbon is relatively small, the covalent bond formed by carbon is relatively small, the covalent bond formed by carbon is relatively strong. Okay. These are some reasons why carbon make a large number of compounds. Then this is just introduction, right? Just we started organic chemistry. There will not be question in your exam paper like what are the reasons to form large number of compounds by carbon. There will not be question like that. Organic chemistry is a huge part. There are so many advanced questions that can be prepared from organic chemistry, not like this type of simple thing. Right? But we need this information as an introduction. That's why I'm giving it. Next thing, before next part is to introduce you the functional group. But before that, I should show you some famous way to write the structures of organic compounds. I know you already know these things, but let's do that one also. Then this is complete. When you draw the structures, you have to be careful. There are several ways. Then once you consider formula, there are several formulas. Empirical formula is one thing. Molecular formula is another thing. The other one is the structural formula. But in organic compounds, we have displayed structural formula, condensed structural formula, and there is some skeleton also, but that's not in our syllabus. Therefore, I don't go to that structure. I just show you these things. As example, I take empirical formula like C1H2. Molecular formula, I take like C3H6. Empirical formula, molecular formula. You learn that one under Unit 3 chemical calculation. Right? I'm not going to explain that one here. So once you consider molecular formula of this type of organic compounds, we can draw the displayed structural formula. But in that particular case, you should know you should have some idea about the valencies of these elements. What about the valency of carbon? Generally, it's 4. In organic compounds, carbon show 4 valency. Hydrogen, valency 1. If you have oxygen, valency 2. If you have nitrogen, valency 3. If you have halogen, valency 1. These are general elements we find in organic compounds according to our syllabus. And these are the valencies of these elements. So valency 4 means around carbon, there should be 4 bonds. Valency oxygen 2 mean around oxygen, there should be 2. 2 should be satisfied. So likewise. Then you can see here, C3H6. C3H6 can be drawn in this manner. There are 3 carbon atoms in this manner. Now I'm going to give hydrogen atoms for carbon until the valency of carbon satisfied. I mean, 4 valency satisfied. Here, if I keep single bond, there are 3, then it should be CH3 like this. Here, if I keep then carbon like 4 here, then there is a problem. There are 6 only, then 5 already used. Then here we have only 1. Then we can have a problem. I mean, I can't put double or triple here. In that particular case, carbon valency here exceed 4. It can't be. So therefore, in these cases, what happened? Middle carbon can have only 1 hydrogen. Other carbon can have another hydrogen. Why I put like that? Because then I can satisfy this 4 valency of carbon by putting a double bond here. This is identified as the displayed structural formula, because that structure represents how these 3 carbon atoms bonded with 6 hydrogen atoms. But same thing can be given in condensed formula also. Without giving all these things in detail, you can just write the structure in this manner also. CH3. This carbon attached to 3 hydrogen, CH3, and this carbon attached to only 1 hydrogen. This carbon attached to 2, since there is a double bond, you can just show that one in this manner. This is what? Condensed structural formula. Remember, I assume you know nothing about organic chemistry. I go to the zero level. From the zero level, I am explaining this one. Maybe you know these things. It's okay, good. But wait, right? Because we have some more advanced concepts later. I take another example, like let's say you have CH2O. This is a kind of empirical formula. I take the molecule formula like C3H6 121. I take it like that. Then better you take it like no, it's a quite a complex one. Let's take C2H4 and O2. You know how to convert the empirical formula to molecular formula, ne? You just multiply the empirical formula by certain integer, then you end up with what? Molecular formula. If I consider C2H4O2, how can we complete this one? There are many ways. For C4, if you are given molecular formula C2H4O2, there are several ways we can draw this structure, but I show you only one possible way here. One carbon and another carbon. I take both oxygen atom attached to this carbon and have OH group also. Then this carbon should have the other 3 hydrogen. I told you there are many ways here, but I select only one option. Later you will understand under isomerism, we will discuss what are the other ways we can draw for this given molecular formula. That is simply isomerism part. So if this is the displayed formula, you know how to write it. CH3, then you get C, 2 oxygen and hydrogen. CH3COOH. That's the condensed structural formula. Or sometimes you can write it in this manner also. Still it is carboxylic acid, same compound, acetic acid. So likewise then, when I then continue this one, sometime I will draw displayed structural formula. Sometime I will draw condensed structural formula. Then you should know the difference between these two very well. That's why I introduce it and then just continue it. Okay. Right. We are still under maybe page 2. Ne? Page 2, you have space. Still, you have some space, I think, that is to just to draw this one, write this one, because later we will come to more and more structures, but to complete the note, let's write it like this. Ne? Let's start a new point and write it like this. Start a new point and write it like this. In the structures of organic compounds, is it okay for 2026 student to join this class? Yes. It's completely okay. If you have completed unit 1, if you have completed unit 2, then theory wise you are ready to then discuss organic chemistry. But compared to 2025, 2026 will find some challenges, difficulties, but it depends. I mean, if you have a good confidence and if you can work harder compared to 2025, because 2025 now completed several sections. Now they have enough knowledge to understand the concepts in organic chemistry. But 2026, maybe you just started, you completed only first unit, second unit, or third unit like that. Then theory wise, you are eligible. I mean, you can understand the concepts in organic chemistry. But remember, you have to work hard there. If you are ready for that, yes, of course. Although you are 2026, you can try this. It is worth to try. Ne? Let's try it. Right. Go back to the note. What I said. What did I say? In the structures of organic compounds, the common way to, in the structures of organic compound, the common ways to represent the structure, are displayed structural formula and condensed structural formula. Displayed structural formula and condensed structural formula. In these cases, valencies of these elements should be satisfied. In these cases, the valencies of, let's say, atoms, valencies of atoms should be satisfied or fulfilled. Let's say satisfied. Right. Now you can just copy these things. Those are the common valencies of these elements in, according to our syllabus, this is enough. Thereafter, you can copy these things: empirical, molecular, displayed, and condensed structural formula. Just 2 examples enough. Right. So here, why it is important to get this structure in this manner, the reason is, I know sometimes some students are having some difficulties to distinguish some functional groups. That's why I give. Sometimes, then one compound is given like CH3CHO, another compound is given like CH3CH2OH, like that. In that particular case, here first hydrogen, then oxygen. Right? But in this case, first oxygen and then hydrogen. These are 2 different compounds. I mean, this is aldehyde, this is an alcohol. Aldehyde, alcohol. How to distinguish them? The way we write the structure. That's why it is important to know how to draw this displayed structural form and condense the structural formula. Later, we will come to these things and explain it further. All right. Then we know how to draw the structures. Then I can explain active group or the functional group of an organic compound. So why do we need functional group? Why do we need active group? All right. This is how we can understand it. I told you there are large number of carbon containing compounds, millions of compounds available. So then if you study these compounds one by one, is it possible? One by one? It's not possible. It takes a long time. It's not possible. So then we are going to discuss this. We are going to study these properties and all the stuff, properties, reactions, and everything about these compounds by classifying these compounds into several groups. We are not going to talk about the properties of these compounds one by one, but we are going to talk about this generally. We put large number of compounds into one bucket. We put another collection of compounds into another bucket. So how do we classify these compounds? That is based on the functional group. That is based on the active group. Then we are going to understand this active group or functional group properly. Without that, you can't then simply continue this. What is a functional group of organic compound? What is an active group or functional group, or we can say active group, both are same. This is how we can understand it. I try to explain this one by taking this example. Assume you have a boiling tube. This contains this compound, CH3, CH2OH. Right? This is colorless liquid like water. This is ethanol. We'll come to that later. Another boiling tube is there. It has, let's say, benzene. This boiling tube has benzene, C6H6. Both of these two are colorless liquids at room temperature. It appears, both of these two appears like same liquid, but no, one is ethanol, the other one is benzene. Now what I'm going to do here, I'm going to put a piece of sodium, which is sodium. I'm going to put piece of sodium to this one and a piece of sodium to this one. Same substance I add. Then I see some observations there. Any observations? Of course, you can see observations only in one sample. It is here. This is where you can see effervescences, air bubbles, effervescence. A gas evolves. Actually, it is hydrogen. But once you consider this boiling tube, there is no any evolution of gases. What's the reason for this one? Actually, in this particular case, this ethanol, CH3, CH2OH, reacts with sodium to give, don't worry if you don't understand, we will come to that later, react with sodium to give this product and hydrogen gas. But once you consider benzene, benzene does not undergo any reaction with sodium. C6H6 plus sodium, there is no reaction. That's why we don't see any observation here. And then what is the reason for this one? Ethanol reacts with sodium because of this OH group. Since OH group not available in benzene, we don't see any reaction with sodium. Then I identify this OH group as the functional group of this compound. OH group is a functional group. OH group is an active group. Then what is functional group? What is active group? It's the part of the compound, or it's a group of elements or atoms which undergo changes during a specific chemical reaction. That's one thing. Because of the functional group, there is a certain polarity of the compound. Because of the functional group, there is a certain melting point for the compound. Because of the functional group, there is a certain boiling point. So did you understand that one? So the properties, chemical and physical properties of this organic compound mainly predicted based on what? The functional group. If that part undergoes changes during a chemical reaction, that part is identified as what? Functional group. Therefore, if any compound having OH group as functional group, then we put all of them into one bucket, one family. What is the class? If OH group is the functional group, what's the class of that compound? Maybe you learn this one in your level. It is the alcohol. So therefore, if I consider this one ethanol, it's an alcohol. If I consider another compound like CH3OH, here also OH available, then it should be another alcohol. If I consider another compound like this, don't worry, I'll cover that later. OH is available. This is also an alcohol. Do you understand it? So that is the importance of functional group. We can predict the chemical properties. We can talk about the variation of physical properties, right? For all these things, the responsible one is what? The functional group. Got it? That is functional group. That is active group. Based on these functional group and active groups, we can classify compounds into several families. In the printed note, I have given actually these classes and everything. He's a friend of mine from so college. He took 40 plus. Do you remember the name? Is that Sahas? Right. You understood what is functional group. Then under the functional group, you see, I have given in the page number 4, I have given some functional groups. Forget about the prefixes and the names and all stuff. We'll come to that later. Now I'm going to list out some other functional groups and the classes. He's Sahasne. Yes, yes. I remember. So we can, I can give the proper guidance, but it's up to you. Eh? Work hard, achieve the target. It's completely up to you. What I can give actually is simply the guidance. That is also very important. Without that guidance, you can't achieve it. Right? Okay, let's go to functional group. Today, I want to complete this introduction. Still, it is introduction part. Thereafter, I should start nomenclature. At least we should complete some part of nomenclature. Today, we won't be able to complete this IUPC nomenclature completely. Therefore, I will arrange another live class on next Saturday also to finish this. So then maybe you are from same school, Mahendra. Right, look at this one. Now I'm going to explain the functional groups one by one, but the order given in that table, in your printed note, the order given in that table is different from this one. It's completely okay, right? There is no certain order. There is an order. I will explain that later. I take it in this manner. So when you consider the functional group C double bond O and OH, and this side, it can be carbon mainly, or even hydrogen possible. Right? So here you can see blue part clearly. This blue part is the functional group, C double bond O OH. Yes, you can see it. Ne? Yeah. Blue part. Wherever you see C double bond O OH, the class of the compound is carboxylic acid. I just write it in this manner, carboxylic acid. Example can be like this, then CH3, C double bond O OH. You see? This part is the main part to identify carboxylic acid. In this side, it can be, this carbon can be attached to hydrogen or carbon, mainly carbon. Sometimes it's hydrogen. Only in one place, it's hydrogen. Next functional group can be like this. If this is attached to, I mean, C double bond O, and again carbon. I mean, I put it like CH3 as an example. This side, it can be again carbon or hydrogen. So the functional group is this one, C double bond O. Instead of hydrogen, you have carbon, means simply alkyl group. Later, I will explain it. So those type of compounds are known as what? Esters. This is, I know, simple, but although it is simple, This is the most important part before you name the organic compound. First step is to identify the class of the compound correctly. So if you can understand, identify it, then that's fine. Then example can be like, CH3, C double bond O, CH3 like that. Here, I can say this whole part is the functional group. Carbon must be there. If it is hydrogen, it's carboxylic. Then if it is carbon, then only it's ester. Another functional group, I can show it like this. If it is C double bond O and NH2. This side, it can be carbon or hydrogen, but hydrogen is not that much stable here. Mainly carbon, mainly carbon. Then if this is the case, we identify this as an amide. Some example I can give like CH3, C double bond O, NH2. The functional group is this part. Wherever you see CONH2, you identify it as an amide. Another functional group, COX. COX, this carbon, hydrogen is very unstable here. So carbon, these are called acid halide. Acid halide, the class. This actually X can be either chlorine or bromine. You don't have fluorine, you don't have iodine, those are unstable. X means here halogen, it can be chlorine or bromine. One example for that one, I can take like CH3, C double bond O, Br. So what is the functional group here? COBr. COBr is a functional group. Those are acid halides. Another functional group, I take it like, what if you get CN? CN, carbon, nitrogen, CN. This is definitely carbon. There is no possibility to have hydrogen. You know, if it is hydrogen, then it is HCN. It's not organic compound. So if CN attached to carbon here, we identify this as a nitrile. We call it nitrile. Example can be like CH3CN, you see. Ethyl nitrile. It's a nitrile. Another functional group, I take it like this one, CHO. This side you can have carbon or hydrogen. CHO group. But if I draw the displayed formula, it can be C double bond O and H, right? This is the displayed formula. Condensed formula is CHO. But we get here, the type or the class is aldehyde. One example for this, you know, CH3, CHO, acetaldehyde, aldehydes. You have heard about cinnamaldehyde. Cinnamaldehyde, the component, the functional group is what? Aldehyde. I mean, CHO group. Cinnamaldehyde quite special in Sri Lanka. These are some functional groups, but there are some more. So I'm going to erase this one. You can have simply screenshot or something. All of these things given in the printed note that has colorful representation, therefore you can easily understand them. If you want, you can have a screenshot or something, or even actually you can go through the video again and understand it. Let's continue the other functional groups and understand the class of compounds. I stopped there in aldehyde. The other functional group can be like this: C double bond O and both side carbon. Both side carbon. If this side hydrogen, I told you aldehyde, COH, aldehyde. But if both side carbon, we identified as what? Ketone. Ketone. Example can be like CH3, C double bond O CH3. This is a ketone. Next functional group, I can put it like OH. But this side, it must be definitely carbon. It can't be hydrogen. If it is hydrogen, what is that? If this is hydrogen, what is it? HOH. Water, ne? H2O, water. It's not an organic compound. Carbon must be there. Then only we identify this class as alcohol. Alcohol. I can give the example like CH3, CH2, CH2O, OH. OH we identified as a functional group, so it's an alcohol. In the example, I took alcohol. Another functional group is NH2. NH2 is another functional group. This is again definitely carbon, not hydrogen. If it is hydrogen, it's ammonia. If it is NH2, the functional group, we identify this as amine. This is an amine. And I can give the example like CH3, CH2, NH2, you see. That is an amine. Next, I take the example halogen. Halogen directly attached to, again, carbon, not hydrogen. If it is hydrogen, you know it's hydrogen halide. If halogen directly attached to this halogen can be, in this particular case, it can be chlorine, it can be bromine, or it can be even iodine. Chlorine, bromine, iodine, not fluorine again. These type of compounds are known as alkyl halides. Alkyl halides. Example like CH3, CH2Br, like that. Next, I take the functional group like this one. I mean, oxygen in the middle, both sides you have carbon. You see here, carbon oxygen double bond in the middle, both sides you get carbon, then it's a ketone. Here, oxygen in the middle, both sides carbon. So what is it? We identify it as an ether. It is an ether. One example like CH3, CH2, OCH3, methyl ethyl ether, or ethyl methyl ether. That's an ether. Right. These are the basic thing, but other than that, you can have these things also. What is that? You already know these things actually. CC triple bond. CC triple bond. CC triple bond is identified as what? Alkyne. Example, CH3C triple bond CH. You know, according to valencies, I decide there is one hydrogen. You can understand it. Other than triple bond, you can have CC, what? Double bond. If you get CC double bond, what is it? It's called alkene. Class is alkene. Example can be like CH3, CH double CH2. Finally, you get CC single bond. We identify them as what? Alkane. Example like CH3, CH3. Then in our syllabus, according to our syllabus, these are the classes we will discuss according to our syllabus. Okay. Carboxylic acid, ester, acid halide, amide, nitrile, aldehyde, ketone, alcohol, amine. What else? Alkyl halide, ether, alkyne, alkene, and alkane. Those are the classes we will discuss throughout this section, organic chemistry. Right. Let's have a screenshot or something if you want. This order is important. The order I gave you here is quite important. That's why I asked you to have a screenshot or something. In the printed note part, I have given all the classes, but except one thing, I think acid halide not available. Ne? Acid halide not available, but I gave it. I hope you got the note. Acid halide not available in the printed note part, but I gave it so you can manage it. Right. These are the functional group. These are the classes. But before I go to these classes one by one, there is very famous classification. There is no functional group there, but all of you have heard about that one. So what is that? Have you heard about hydrocarbons? I know still this is introduction, right? I know most of you are okay with these things and you may think like, oh, what is this? This is nothing. We need organic chemistry, advanced organic chemistry, you may like in that manner. But later I will show you these basic things are really, really important to understand the concept. When you are going to do the questions mainly nomenclature, definitely you may do some mistakes there. I have seen that one in physical classes many times. I know they're common mistakes. That's why I'm explaining these things in detail. It's okay to start from this very basic thing. It's not wasting time. We have time. The thing is understanding the concept properly. That's the main thing. Another classification, what we have, hydrocarbon. All of you know these things. What is a hydrocarbon? You may have answer. You will say the compound which has carbon and hydrogen, those are hydrocarbon. Yes, correct. But do you know this hydrocarbon, there is classification. Even in hydrocarbons, there is a classification. Do you know that one? This classification is done mainly aromatic and aliphatic. These terms are quite advanced. I mean, you have never sometime heard about these things, but it's okay. It is very simple one. Aromatic and aliphatic hydrocarbons. What is the meaning of aromatic and aliphatic? Main thing is this one. Both of these two contain only carbon and hydrogen. That's very clear. Both of these two has only carbon and hydrogen. That's clear. But aliphatic aromatic means in the case of aromatic, there is stabilization, extra stabilization of the compound due to the delocalization of pi electron cloud. Due to the delocalization of pi electron cloud, there is extra stability. But we don't see that one in aliphatic compounds. But what is delocalization of pi electron cloud? Then we will come to that later. But I'll show you one example, one famous example in our syllabus. This one, C, 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 C. And each and every carbon has hydrogen here. Each and every carbon has hydrogen. Then to satisfy the valency of carbon 4, you get a double bond here, double bond here, double bond here. What is this? This is an example for hydrocarbon. Aromatic hydrocarbon, it is benzene. This is benzene. Okay. So this benzene actually example for aromatic hydrocarbon. In this aromatic hydrocarbon, you see, we get the structure like this. We call this type of structure like conjugated one. This is cyclic structure and it is conjugated. Conjugated system mean alternative single and double bonds available. You see, single bond, thereafter double bond, single bond, thereafter double bond, single bond, thereafter double bond. When you get this type of arrangement in the structure, these pi electrons can be delocalized. And the benzene, I will explain that one in detail. With the hybridization and everything, overlapping part and everything, we can understand it. So just remember that one. In the case of aromatic hydrocarbon, we need this type of structure. It's not always cyclic, but we need this type of conjugate system, alternate CC single and double bond. Then only the delocalization of pi electron can happen. Then only this extra stability can be introduced. But once you consider aliphatic, you don't have this type of conjugate system. Aliphatic hydrocarbon can be cyclic or can be acyclic. Aliphatic again can be divided into two parts. One is acyclic, the other one is cyclic. Acyclic means there is no cyclic structure. The other one is cyclic. Cyclic means cyclic structure is there. Actually, if you take same cyclic structure without these pi bonds, it is aliphatic, because without pi bond, you don't have that extra stability. There is no delocalization of pi electron cloud. So I draw the structure here, same structure, without that pi bonds. It is a cyclic structure. But now, if you don't have a pi bond here, each carbon should have 2 hydrogen to satisfy the 4 valency. All of you can understand this. To satisfy the 4 valency, each carbon should have then 2 hydrogen atoms. Here actually only 1 hydrogen atom. The formula here, molecular formula C6H6, benzene, C6H6. But this one is not C6H6, this is C6 but H12. We call this cyclohexane. Cyclohexane. I'll come to that later. No need to write anything. But I want to show you the differences in these classification. But in acyclic, again, there can be 3 types here. Acyclic hydrocarbons can be found in 3 ways. These are very simple things. That's why I'm explaining it a bit quite fast. One is alkane. All of you know that. I already explained. Alkane is something having single bonds. You see CH3, CH2, CH3. It's a hydrocarbon because it has only carbon and hydrogen. It's an alkane because it's single bond, no pi bonds. And it is aliphatic because there is no ring structure, there is no conjugated system. Therefore, it's aliphatic acyclic structure. Another example for acyclic aliphatic compound, alkene. Alkene is another example. Alkene means double bond available. I can take this example like CH3, CH, double bond, CH2. This one is alkene, but it is acyclic. There is no cycle. Then someone can say like this, okay, then double single available. Can't there be delocalization and extra stability? No, it can't be. I will explain that one later under the hybridization, delocalization. That part I will explain it. Here, just pi bond and single bond available. Because of these 2 bonds, there cannot be delocalization. Pi electrons are always found here in between these 2 carbon. But in this case, we can't say like that. The resonance structure in bonding you learn because of this formation of resonance structures. Here, pi electron can be delocalized, but this can't make resonance structure. And it's not cyclic. Another acyclic type is alkyne. Another acyclic type is alkyne. Alkyne means triple bond. As example, I can give CH3, C triple bond, CH. This is the way we classify hydrocarbon. Hydrocarbon is one family. Then other than hydrocarbon, you have the other families. Alcohol, ketone, aldehyde, carboxylic acid, everything. So I hope now you understood some basic thing regarding the classification of organic compounds according to the functional group. Mainly we have one family hydrocarbon. Under hydrocarbon we have several classifications. Other than hydrocarbon we can have some other classes according to the functional group. Correct? Right. Then other functional groups and classes available in the printed note, but hydrocarbon is not given actually. That is to write the note. Maybe now you are in page number 3. Page number 3, you know, the top we have subtopic functional groups and classes of compounds. Under that, some printed part is there. Then bottom, you have some space to write the note. Bottom, you have some space to write the note. Okay, let's go to the note. Write the topic there. Write the topic in that space. Hydrocarbon. 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 Under that, write it like this. Hydrocarbon are organic compounds containing hydrocarbons are organic compounds containing carbon and hydrogen only. Hydrocarbons are organic compounds containing carbon and hydrogen only. These hydrocarbons can be classified. These hydrocarbons can be classified mainly into aromatic and aliphatic. Aromatic and aliphatic. Aromatic and aliphatic. Aromatic hydrocarbons have cyclic structures. Aromatic hydrocarbons have cyclic structures which are stabilized by delocalization of pi electron cloud, which are stabilized by the delocalization of pi electrons, or simply pi electron cloud. Stabilized by delocalization of pi electron cloud. Aliphatic hydrocarbons can have open carbon chain. Aliphatic hydrocarbons can have open carbon chain or cyclic carbon chain. Aliphatic hydrocarbons can have open carbon chain or cyclic carbon chains. But these structures do not have the stabilization due to the delocalization of pi electron cloud. these structures do not have stabilization due to the delocalization of pi electron cloud. Okay. Then aliphatic classified into these two, but it is there in the node. So better you copy this chart roughly. That is enough for that classification part. Just copy this chart. This part you can't see. In this case, what you have actually carbon, single bond, carbon, single bond, and each carbon having 2 hydrogen. Okay, I hope you completed the table, the chart. Then one thing now you can do in organic chemistry. What is that? If I give you the structure of organic compound, you can identify the class. Is that important? Yes, it's very important. In the case of nomenclature, that's the most important part. Without identifying the class, you can't do anything. Okay, then tell me, what is this? CH3, CH2, CH2, OH. If you identify the class of this compound, just type that one in the chat box. Hurry up. Identify this compound and write the class. Send me the class in chat. Go, come on. Maybe it's difficult for maybe some of you then watching this one through the phone. In that case, it's quite difficult to, yes, type it. I know that. At least one. So if I ask what is the class of this compound, what will be your answer? So I know you are waiting for the others. Ne? I don't have to answer. Someone else will answer this one. Is that the case? Oh, you didn't identify it. Yes, in this case, we identify this OH group. The compound is having OH group. The one which has OH group is identified as what? Alcohol. Yes. But sometime you have the compound like this. Look at this one, CH2CH. You get OH and you get COOH like this. The compound is given in this manner. In that case, how do you identify the compound? The class of the compound. What could be it? It is OH available. Because of that, you identify it as an alcohol. COOH available. Because of that, you identify it as what? Carboxylic acid. Because of alcohol, because of OH, it's alcohol. Because of COOH, it's carboxylic acid. Then we have a problem. Then what is this? It's alcohol or it is carboxylic acid. In this particular case, actually, we think about what? We think about the priority. These functional groups are having certain priorities. The one which has high priority is the one we consider to identify the class. Out of carboxylic acid, alcohol, which one has the highest priority? That is the order I gave you. In the printed note, we have functional groups here and there, but the order I gave you in the board, that is the priority order. First, I place carboxylic acid. You remember that one. Then carboxylic acid has the highest priority. Thereafter, I place ester. Thereafter, I place then acid amide. Thereafter, acid halide. So, likewise, that order is the priority order. Then you see, once you follow that order before alcohol, OH, you meet what? COOH, carboxylic acid. Therefore, remember, this is not alcohol, it is what? Carboxylic acid. So if you have the compound with more than one functional group, to identify the compound, the class of the compound, definitely you have to consider the priorities of compound, priorities of the functional group. The one which has high priority should be the one. Got it? Right. Then that should be written actually in the note. In the note, you see the page number 5 top. Page number 5 top. Some spaces available. That is to write the note. Okay, let's have the note like this. If the compound has more than one functional groups, if the compound has more than one functional group, the class of the compound is identified. The class of the compound is identified. Class of the compound is identified according to the priority of the functional group. According to the priority of the functional group. The one which has the highest priority, the one which has the highest priority The one which has the highest priority decides the class of the compound. The one which has the highest priority decides the class of the compound. Okay, shall we copy these two examples then? Here only one, therefore it's very clear, alcohol. This compound has two, but according to the priorities, it's carboxylic acid, not alcohol. Just copy these two as examples. Okay. So then I have arranged one simple question number one. Here there are some compounds given. Then the question is to identify the class of the compound. Shall we do that one? It's a simple one, I know that one, but let's do it. Simple but important. Let's do that one. I will give you about 3-4 minutes. Everyone should do that one. Okay, I hope you completed question number one. So in question number one, there are 8 compounds given. The question is to identify the class of the compound. I hope all of you have done this correctly. First compound, let's see whether you have identified it. In that compound, you see, you have only a carbon-carbon single bond. Because of that, we identified as what? Alkane. Second compound, I think you have the tube. It is there in the description. You can simply download it and refer it. Second, CH3CHBr is available. CHBr is available. Then carbon, hydrogen, halogen. So what could be that? It's alkyl halide. Alkyl halide. You can write it in this manner, or you can say alkyl bromide. Since bromine is given, we can identify it as an alkyl bromide. If Cl is available, it's alkyl chloride. So likewise, third compound given, then this is the thing sometime. The compound is given like this: CH3, CH2, O, CH2, CH3. This is what you are given. So what is that? As you can see, oxygen in the middle, both sides you have carbon in this manner. If you remember that table, it's ether. We identify this as an ether. Fourth compound is given in this manner. It's CH3CH2, CH2, CH2, 4 carbons given. No, 3. Thereafter, you are given COCH3. Right? So very small difference is there. So when I displayed this one, so how do we get it? C double bond O and C. This is how we have it. You see the difference between these two. So this is ether. This one is what? Ketone. We identify this compound as a ketone. Fifth one, it's clear. We have two types. I mean, ether available, amide available, but according to the priority, we identify this compound as an amide. Once I follow that order, you meet amide before you meet ether. That means amide has higher priority than ether. So that's why I identify fifth one as an amide. Sixth one, you get alcohol, you get carboxylic acid, but you know, out of all the classes, carboxylic acid has the highest priority according to our syllabus. Then seventh one, you get a double bond and COCl. Can you see that? It's CH3, CH double CH. It's given COCl. COCl. You can draw the displayed formula like C double bond OCl. So what is that? Acid halide, double bond alkene, but acid halide is higher priority. So we identify this as acid halide, mean in this case acid chloride, because chlorine available. That compound is acid chloride. Last one given, eighth one, CHO, CO2, CH3. Could you identify that compound? Eighth one, what could be the class? Eighth one, you can see I have given it in this manner. It's I hope you have the tube. It's in the description. Condensed formula given like this, but better you draw the displayed formula and then I identify it. These are the places sometimes you make mistake. I know you are expert in functional groups, but once I give a compound in this manner, what is that? That's what I want to overcome here. So displayed formula, you know, CHO group, I told you, if it is given CHO, it's double bond O and H. CO2CH3, 2 oxygen attached to carbon. So we can draw the displayed formula like COO CH3 this way. Once you draw the displayed formula, it is easy to identify. You know, CHO group is what? Aldehyde. C double bond O CH3. What is this? Ester. But out of aldehyde and ester, which one has higher priority? Ester. Before you meet aldehyde, you meet ester. Means ester has higher priority. So therefore, we identify this compound, eighth one, as an ester. So this is the introduction simply. I mean, now you have ability to identify the class of the compound. Eh? If I give you any structure, you can identify the class of the compound. Why I explain that in detail in this manner, although it is very simple basic thing, that's because it's the main requirement for the next topic, nomenclature part. So if you want to understand the nomenclature well, or if you want to name the compound correctly, this is the first thing. Identify the class of the compound. That's the main thing. Without that, you can't do the nomenclature correctly. Then the thing is this one, then someone can say nomenclature is not so important because you get only one MCQ or something. But no, it is very important. One MCQ means 1 mark. 1 mark, then 1 plus 1, 2, 2 plus 1, 3. So that's the way the mark then increases. Even 1 mark is very, very important. It can change the result. So therefore, it's not, then we can't say like that, it's not important. It is definitely important. And the other thing is, in organic chemistry, the other questions can be given as a combination with the nomenclature. The isomerism question, conversion question, all of these things can be given as a combination with the nomenclature. Without giving structure, what happens if the IUPAC name is given? In some past papers, they have given like that. Without giving the structure, they have given the name. Then that's why, again, the name is important. Although you know the reactions and everything very well, but if you can't do the naming correctly, then you end up with the wrong answer. You lose marks in vain. So that is why nomenclature is important. For the nomenclature, this part is important. Identifying the class of the compound. Right. Then I'm going to start now nomenclature part. I hope you're okay. You can continue one more. Or do you need a small break? Do you need about 5-minute break? If you need, you can just put that one in chat. Right. It seems that you don't need any break. Right. Let's continue with then. Right. Yasmin, I think you don't need it. Ne? Here there is a small delay between the Zoom class and the YouTube one. There is a 20-second delay, I think. Then when you response it, I don't know you response it for what. I just continue it. If you need break, just type break. Then I can give about 5 minutes break. Or if you don't need, yes, it's okay. We can continue it. IUPAC nomenclature. That's the main topic. How to name a compound systematically. That is the point here. Then there are several ways to name. I mean, there are mainly two ways to name a compound. There is a systematic way, or there is a irregular way. IUPAC name, the systematic way. The other one is trivial name. But in the case of trivial name, we have some limitations. We don't have trivial name for all the compounds. That's the problem. But once you go to IUPAC name, yes, for all the compounds, we can get a name. Then mainly we focus here how to name compounds systematically. IUPAC name. That's what we are going to discuss here. Right? But the thing is this one, then why can't we name a compound easily? The reason is, in the case of naming organic compounds systematically, you have large number of rules. You should follow large number of rules to get the name correctly. Then why is it so then difficult sometimes? Because we don't like to follow rules. Not only organic compound, actually, if you are going to name any compound, anything, definitely you have to follow some rules. Just consider your pet. Maybe let's say you have a dog. If you have a dog, do you put the name like Kitty or something? We don't say like that, because Kitty is for what? Cats. Even the dog available, if it is male, female, again, there are some rules, like Lassie, Tommy. Then rule Tommy for male, Lassie for female. So likewise. And then your friends have some nicknames. Maybe you too have the nicknames. Then once you consider that nickname, definitely, if you have a nickname, there is a reason for that. Maybe that's because of your appearance. Maybe that's because of your certain behavior. Your friends then have put that type of name. Or if you put a nickname for friend, you follow those things. So likewise then, once you are going to name organic compound, it's not just 1 rule, 2 rule, 3 rule, 10 rule. It's large number of rules available. Due to the complexity of these rules, sometimes you may find difficulty to name organic compound, but it is not difficult. It is very easy. If you just follow the rules properly without skipping anything, definitely you end up with the correct name. Okay, let's talk about these rules then. But I will discuss these rules in 3 steps, mainly 3 steps, but let's take 4 steps. I will discuss these rules in 4 steps. What is step 1? Step 1, as I mentioned, identify the class of the compound. That's what I told you. It is the first step. Identify the class of the compound. Then how do we identify the class? Based on the functional group. Now I explained that one in detail. I hope you are okay with that one. Then step 2. Step 2 is this one. Identify the main carbon chain of the compound. Now we have a problem. In second step, I have to explain this in detail. So what is the carbon chain? First, we should understand that. Now we are going to talk about the aliphatic compound. Aliphatic compound means it's not cyclic one. We have open carbon chain one. In our syllabus, we don't go to that naming aromatic compounds. It's not there. We talk about aliphatic compounds only. Even in aliphatic, we consider open carbon chain. I take several compounds, the structures. Look at this one. I take, let's say, 3 structures like this. I draw only carbon atom, the chain. There are some other hydrogen or some other atoms available, but I just ignore them. Next thing like this. Then another, I take it like this. You see? I took only 3 examples to show you the compound may have more than one carbon chain. When you select carbon chain, the first thing, you can't start it somewhere in the middle. Definitely, you should start from one of this end, maybe this end, maybe this end. And it's consecutive carbon atoms. These two not separated by any other atom. Carbon, 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 carbon. Then you see, and next thing, you can't stop it somewhere in the middle. Definitely, you should go to the other end. Then in the case of first carbon, I mean the first compound here, it's very simple because only one carbon chain available. If only one carbon chain available, that could be the main carbon chain. No problem with that. But what about the second one? In the case of second one, I start from this. I told you, I asked you to start from one of them and don't stop somewhere in the middle. Just continue until you meet the other end. This is one carbon chain available. Is that only carbon chain you can have? No. If I label this one as this is first one, but look at the second one like this. One can start from this carbon, this end. We can continue up to this carbon, right? But without going straight, one can go down. Because I told you carbon chain means consecutive carbon atoms. Carbon, 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 then someone can go to down. Doesn't matter because we have carbon-carbon bond. This is the second carbon chain I can identify here. Is that only? Don't you have another carbon chain here? Yes, we have. Look at this one. Without starting from this end, I try to start from this end. I start from that end. Then I come to this, up to this carbon. You can go straight. If you go straight, it's same as first one. Without going straight, you can come down. What is that? It is the third one. It's a new carbon chain. Third one. Now you can see in the second compound, more than one carbon chain available. Actually, there are 1, 2, 3 carbon chains available in the second structure. Go to the third one. I mean the third compound. There are several ways you can have. One can start from this carbon and finish from this. One can, another way, we can start from this carbon and come to this carbon and go up. Another way, one can start from this carbon and come to this and then go down. That's also possible. Another way, without starting from this carbon, one can start from this carbon. Come to this carbon and go up. Come to this carbon and go down. You see? Another one can start from this carbon. I mean, without starting from this one or this one can start from this carbon. Then go to this carbon and come to this and go to this. So likewise, in the case of the third carbon compound, organic compound, you have many carbon chains. There are several possible carbon chains in the case of third compound. Now the question is, which one is the main carbon chain? Then step 2 is that one. You have to identify the main carbon chain. Right. It is not easy to identify the main carbon chain because there are several things you should consider. Then what is the first thing? Remember it like this. If you want to find out the main carbon chain, remember functional group should be available in the main carbon chain. Functional group should be available in the main carbon chain. That's a requirement. In that case, then if I just take this one like C double bond OH in the second compound, first compound, it's okay, just one carbon chain available, then no issue. We don't need any condition here, just that's the main carbon chain. But if the compound has more than one, like second one, main carbon chain should contain the functional group. Then you see, if it is carboxylic acid, that's the functional group, highest priority, that's a functional group. Then that must be in the main carbon chain. It should belong to the main carbon chain. According to that, I can easily ignore second one. Because if you move from this carbon to this carbon to this carbon, you see, does this carboxylic acid part belong to the, no. Main carbon chain does not have carboxylic acid. It is outside of this one. Then it can't be the main carbon chain. Then it can be either first one or third one. So that's the main thing. Next part, I take, let's take here, I take OH group. Let's say OH is the functional group here. OH group is the functional group. Then you can see, you can easily ignore this red one, this blue one, this green one, because OH must belong to the main carbon chain. Therefore, definitely it should be one of these three. Got it? So that's the first thing. But sometimes, having this condition will not give the main carbon chain. As example, here still two possibilities are there. So because of that, you need to go to another. If double bond or triple bond available, then you have to be careful. It must be in the main carbon chain. This double bond or triple bond should belong to the main carbon chain. But here, let's say you have, there is double bond here. Then what happened? Now we have two options, either 1 or 3, because in both of these two cases, the functional group is there. Now the problem is, what is it, first one or the third one? Then according to this condition, you see, double bond must belong to the main carbon chain. So in that particular case, you see, you can easily select first one. It can't be third one. Because if it is third one, you come to this carbon and go down. Once you come to this carbon and go down, double bond is not there. It is outside of this chain. Therefore, third one cannot be the main carbon chain. If double bond is available here, first one must be the main carbon chain. These are the rules I told you. First, try to understand the rules. Once you understand the rule, the 50% of the problem solved. Let's say you don't have double bond. Then still we have a problem with the first one or third one. Then we have one more condition. The condition is this: there should be maximum number of substituents. There should be maximum number of substituents. Then I use a new word, substituent. What is substituent? Definition for substituent actually, other than hydrogen and the functional group, any other atom or group of atom attached to the main carbon chain is a substituent. I know at the beginning it's quite difficult to identify the substituent. At the beginning it's quite difficult, but it's not difficult once we go through several examples, and I will show you how to identify the substituent. From that you can simply get that idea. Hari? So here, then second one I ignore it. It can't be the main carbon chain. Now we have two options. It is either first one or the third one. Hari? No double bond, no triple bond, right? But look at this one. Assume there is Br atom attached to this carbon. It's given Br atom attached to this carbon. Then how do we identify Br atom? Br atom is identified as a substituent because it's not hydrogen, it's not a group of, it's not hydrogen, it is bromine. It's not the functional group. Now functional group is carboxylic. So because of that, we identify this Br as what? A substituent. Then once you come to this junction, see, and go straight, you meet substituent, one substituent. But if you come to this junction and go down, do you meet any substituent? If you come to this junction and go down, do you meet any substituent? No, we don't have. Then I told you there must be maximum number of substituents to select the main carbon chain. Then once you go straight, you meet one substituent. Once you go down, you meet zero substituent. Then what is main carbon chain? First one or third one, according to that rule? Once you go straight, you meet one, but when you go down, you have zero. If you consider maximum number of substituent, then it must be definitely but straight, first one. That is the thing. But sometime, let's say no bromine available. No bromine available. Still, it is this. Then we have problem here. Which one is the correct one? Then look at this one. Final thing is this one. There should be maximum number of carbon atom. There should be maximum number of carbon atom, or simply longest carbon chain. But I didn't put that one at the beginning. The reason is, remember, for a given compound, we can't find first the longest carbon chain. It's not the main carbon chain, because these conditions should be satisfied. Then only, if all these things satisfied, then longest carbon chain should be the main carbon chain. But don't then come first to maximum number of carbon atom, the longest carbon chain. It's wrong. Step by step, we check the condition, then only we find out the main carbon chain. Then look at this one here. Functional group, right? Double, triple, not available. Substituent, not available. Then we come to maximum number of carbon atom, because still we have doubt whether it is first one or the third one. We have doubt. Then look at this. Once you come to this junction, stop there. Once you continue with straight, how many carbon atom added? 2 more carbon atom added. Come to this junction, stop there, go down. How many carbon atom added? Just 1. If you find out, if you find out first one as the main carbon chain, you see you add 2 more carbon atoms. Total become 1, 2, 3, 4, 5. Number of carbon atoms. And if you select third one as the main carbon chain, you add only 1 more carbon. Then total 1, 2, 3, 4. Then 5 carbon atoms, 4 carbon atoms. Then you see we end up with finally the main carbon chain. it should be definitely the first carbon chain. That is the way we find out the main carbon chain. It's not easy. Got it? Then sometime you follow all these things, but finally, still you have 2 or 3 possibilities. Doesn't matter. Select one and then name it. Then definitely you end up with correct answer. Okay. Now we need to maintain the note for this one, because there are some spaces to write the note in page number. Yeah, naming a compound, nomenclature of compound in page number 6. Page number 6, we have some spaces there. Then it is to complete the note. Let's start the note like this. Write it like this. In naming the organic compound systematically, there are several rules. That should be considered. These rules can be discussed. Under 3 steps. These rules can be discussed under 3 steps. Not 3 actually, let's put 4. I took the first one also, identifying functional group as another step. Let's put like 4 steps, right? 4 steps. Okay, then write step 1. Write step 1. Under that, write it like this. Identify the class of the compound. Identify the class of the compound. According to the functional group. Identify the class of the compound according to the functional group. It's done in the first part. Then write step 2. Write a step 2. Identify the main carbon chain. Identify the main carbon chain. Under that, we write down, for a given structure, there may be more than one carbon chain. For a given structure, there may be more than one carbon chain. The main carbon chain is identified. The main carbon chain is identified according to the following requirements. According to the following requirements. Okay, let's try the requirements one by one. Under that, we need these 4 requirements. Let's try them one by one. Functional group should be present in the main carbon chain. Functional group should be present in the main carbon chain. That's the first requirement. Second requirement, by the second requirement, CC double bond or CC triple bond, CC double bond or CC triple bond. Within bracket, write if available. If available. It's not a must to have a CC double bond or triple bond for a given structure. It may have or it may not have. So that's why I put it like if available. CC double bond or CC triple bond within bracket if available should belong to the main carbon chain. Should belong to the main carbon chain. By the third requirement, there should be maximum number of substituents. There should be maximum number of substituents in the main carbon chain. In the main carbon chain. Next requirement, last one. There should be maximum number of carbon atoms. There should be maximum number of carbon atoms. So simply, it should be the longest one. Within bracket, right? The longest carbon chain. There should be maximum number of carbon atoms. So simply, within bracket, longest carbon chain. In the main carbon chain. In the main carbon chain. But the thing is, this one, in these conditions, it is like this one, and OO. You also that one, and OO. This is and OO. You know why? Because sometimes, just by considering the first condition, you can select the main carbon chain. Sometimes you need first and second. You don't need these two to find out the main carbon chain. So therefore, we always follow this order. When we follow this order, we don't know at which stage we find out the main carbon chain. That's why it is and OO. I hope you understood that one, right? That's the main carbon chain. That's the way we identify main carbon chain. Right. Then I move to step 3. But before I move to step 3, I'll give you 2 structures here to identify the main carbon chain. Just 2 here, just to check whether you got this very clearly. Right, first structure given like this. Now I give all the atoms CH3, CH2, CH2, C. Here CH2, CH, O. Here CH3. And yeah, let's say this is CH3. So you are given a compound in this manner. You are asked to identify the main carbon chain in this compound. Another compound is given like this: CH3, CH double, C, H, C, CH2, CH2, CH3, and C double bond O, CH3, and Br or something. Yes, this is the second compound. Let's see whether you can identify the main carbon chain here. I'll give about 1 minute for this one. That is enough. Just follow the conditions I explain and try to identify main carbon chain. Right, let's see. When I ask you to try a certain question, it's important to try it, right? Because if it is a physical class, definitely then I can come to your place and then check whether you are doing it properly. And if it is a physical class, I can see your facial expressions, and then I can decide, okay, you understood it. You understood it. I can decide it. But in these type of classes, then I don't know whether you understood it or not. I can't see your face. That's why I'm giving some kind of this type of, and next thing, I can't give large number of questions here. It's then quite boring. If it is a physical class, I can give it and I can see, I can check whether you're answering it properly. So I'm giving only 1 or 2 examples. Therefore, it's okay. You take 1 minute, 2 minutes, and then try it. It's okay. You do mistake. It's completely okay. Then when I explain it, then you can understand it properly, because you do some mistake and you understood through the mistake. That is the best understanding. You never forget it. That's why I ask you to do it and see my explanation. All right, look at this. Now, identify the class. Don't forget the first step. Alkane, I mean CC single bond, CH, CH, and CHO. What is CHO? CHO is for what? Aldehyde. All right. I identify this compound as an aldehyde. So if you identify this as an aldehyde, functional group must be in the main carbon chain. Then there are 3 places you can start. You can start carbon chain from this carbon. You can start carbon chain from this carbon, or you can start carbon chain from this carbon. Because there are 3 open ends. Now, which one is suitable? Look at that functional group part. Then functional group must be in the main carbon chain, and functional group is this one, CHO group. Then it's very clear. You should definitely start from this carbon and come to this junction. This is the easiest way. First, look at the functional group, where we get the functional group. Then that must belong to the main carbon chain. That way you select which end. Then I select this end because then only CHO group available. Once I come to this, stop here. Once you meet a junction, stop there. Once I meet this junction, I stop there. Then I think about this. Okay, left or right? Left or right? That's my question. But to decide whether it is left or right, then you go for the other condition. After functional group, what's the next condition? Next condition is double triple. Go to left hand side, no double triple. Go to right hand side, no double triple. Then go to next one, substituents. I told you substituent is something which is not hydrogen or functional group, but any other atom or group of atom. Come to this end, I mean left hand side. Do you meet any other atom other than hydrogen? No, you don't meet. Go to right hand side. Do you meet any atom other than hydrogen? I mean carbon is definitely the main carbon chain. Then other than that, hydrogen? No. Hydrogen is there. There is no any other. Then that is also not important. You go to left, no substituent. You go to right, no substituent. Then go to the next one. Still you have a problem. Then go to the next one. Next one is maximum number of carbon atom. Then you go to left. Once you go to left, you meet 1, 2, 3. You add 3 more carbon atom. Now you go to right. Then you add only 1 carbon atom. Then which one is correct? Main carbon chain. Then it is this one. Your main carbon chain in the first compound is this one. Right. Then you identified it. I hope you did that one correctly. Or if you have done mistake, I think now you understood it. Okay, then someone can think, I mean, we have this problem. Some of you have this problem. I know that once you select this as main carbon chain, what is this? Then now, once you identify the main carbon chain, you identify this is a certain group. It's not hydrogen. It's not functional group. It's certain group attached to the main carbon chain. Can you see these are main carbon chain? These carbon atoms, main carbon chain, you see? To that main carbon chain, this CH3 group is attached. Then what is CH3 group? It is a substituent now. CH3 group is a substituent. Right. At the beginning, I am explaining these things very slowly and in detail because you need the concept. I assume you know nothing about these things. Once you develop the concept, once you understand the concept and develop, quickly you can do it. Next thing, in the second compound, identify the class. That's the first thing. Don't forget it. Double bond mean alkene, Br mean alkyl halide, alkyl bromide, alkane, I mean CC single alkane, C double bond O. This has CC. Then it is ketone. Ketone, alkyl halide, alkene, and alkane. Which one is having high priority? It's ketone. You remember that order? We meet first ketone, then only we go to alkyl halide, alkene part. It's a ketone. We identify this as ketone. Once you identify ketone, this part is functional group. You see? This is the functional group. Carbon double bond O, but carbon carbon. Both carbon should there. 3 carbon atoms should be there. If it is ketone, at least minimum 3 carbon atoms should be there. Then there are 3 ends. You can start main carbon chain. But which one is suitable? Remember, I do not start from somewhere in the middle. I told you main carbon chain should start from either end, not in the middle. Then definitely you should start from this carbon because then only the functional group belong to that carbon chain. But once you start this, you have a junction here, you stop there. Once you start from this carbon, you have a junction, so you stop there. Okay. Then think about the 2 possibilities you have here and here. Then go to the next priority one. I mean, First functional group, then you consider double triple. Is it there? Double triple, is it there? Yes, it is there. Then definitely we should go straight. And we identify this as the main carbon chain. That is the main carbon chain of the second compound. Then what is this? This whole group. You see, any group other than hydrogen or functional group, any group attached to the main carbon chain should be a substituent. Therefore, this one is a substituent. I mean, this is the main carbon chain. This whole group attached to main carbon chain. So it should be what? Substituent. Then I explain that with some example. I hope you understood it. I need your complete attention. It's difficult, I know now, 10:33. Maybe some of us sleep. Maybe in the other day you already sleep. Therefore, I know then there are some difficulties, but you are doing A-level. You are having exam this year. You have only 7 more months. Then sleeping is not excuse. Although you are sleepy, you have to continue it. Therefore, I think you can give me 100% attention, the focus. That's really, really important. That's how we get it. Okay, we completed that part, carbon chain part. Before I go to step 3, I should tell these things. I mean, how to start a carbon chain, and middle you can't stop there. And what is substituent? I didn't give the note, right? Then before I go to step 3, I think better we write this point also. Under step 2, we are writing these things. Start a new point and write this. Carbon chain should start from one of end. Carbon chain should start from one of open ends. One of open ends. And continue continue up to the other end. And continue up to the other end. That means you can't stop somewhere in the middle. And continue up to the other end. Then start a new point and write it. Substituent is the atom other than hydrogen. Substituent is the atom other than hydrogen or group of atoms. Substituent is the atom other than hydrogen or group of atoms that are attached to the main carbon chain. Substituent is atom other than hydrogen or group of atoms that are attached to the main carbon chain. Then substituents can be Br, substituent can be Cl, substituent can be OH, substituent can be NH2, substituent can be CH3. Those are not hydrogen. But these become substituent when there is functional group which has high priority. Otherwise, OH become functional group. Don't write them, later we will come to that. Okay, I think we completed first 2 steps successfully. Identify the class and identify the main carbon chain. Now I move to third step, another very important step. Third step. Today I should complete at least 3 steps. Once I complete these 3 steps, then you are ready to start naming compounds. Nomenclature is not finished. I mean, basic thing is finished under these 3. Thereafter, we go to the different classes and then discuss the nomenclature. As example, we go to alkane, discuss how to name alkane. We go to alkene and discuss how to name alkene. That can be done. Then definitely next day we can finish this nomenclature topic. Today, maybe then basic thing, very simple thing, but I explained that in detail because proper understanding of this basic thing, very important. Then next day, not like this. Next day will be quite fast and easy to continue. Then step 3 also, I will explain that in detail, very slow. This is not wasting time. If time is not enough, then we can arrange another class. We can arrange another class in this manner. Step 3 is this one, number in main carbon chain. Number in main carbon chain. What are we going to do? We are going to assign a number. We are going to assign a number to each and every carbon atom in main carbon chain. Like 1, 2, 3, 4, 5. We are going to give a number to each and every carbon atom in the main carbon chain. Main carbon chain. Remember that one. Right. I take 2 examples and explain. Let's say you have CH3, CH, Br, CH2, CH2, CH3. One compound is given. Easy one. Another compound given CH3, CH2, C double bond OH, Br, CH double CH2. Another compound given, quite complex one. Okay. Right. Now go to the first step. Identify the class. What is this class? Carbon, hydrogen, but Br available. Therefore, this is alkyl halide. This is alkyl halide. It is alkyl halide. Then the functional group Br. Then Br definitely should be in the main carbon chain, but in this case, main carbon chain is only one option is there. Can I start from the middle? No. I told you, main carbon chain should start from one of N and it should go up to the other end. So we identify main carbon chain from here to here and Br belong to that one. Functional group. Now you see this is identified as functional group, not the substituent. Look at the second one. Before that, numbering. How to number it? Okay, remember this one. Once you number it, one can start from this end. Numbering also started from one of end. Open carbon chain, there are 2 ends. Then you can start either from this end or the other end. But the thing is this, if I start from this end, you are going to give number for each and every carbon. Then 1, 2, 3, 4, 5, green one. And what about red one? If someone start from this end, then 1, 2, 3, 4, 5. But remember this one. Both ways are not acceptable. I mean, one of these one is correct. One of this one is correct. Maybe red one is correct, maybe green one is correct. But we should know how to find out the correct numbering. What is the condition for that? Again, we have those conditions. What is it? Functional group or active group should have minimum possible number. Functional group should have minimum possible number. That means here functional group I identify it as Br, but actually this is substituent. In nomenclature I will explain it. But the thing is this one. Now we identify this as a functional group. Then look at this. If it is green numbering, number 2 goes to carbon with bromine. I mean the functional group. If it is a red number in, number 4 goes to that carbon. Then there are two options for the functional group, number 2 or number 4. Number 2 or number 4, which one is correct? Number 2 or number 4, which one is correct? Don't know whether you are all sleeping. So the condition is this, I told you, there should be minimum possible number for the functional group. Then out of 2 and 4, what is minimum possible number? It's 2. Then according to that, remember, green one is the correct number in, red one is wrong here. Let's go to second compound. Hurry. Second compound. First step, identify the class. Alkene, alkane, alkyl halide, aldehyde. Now I think you are okay with the classes and everything. Alkene, alkyl halide, alkane, and aldehyde. So which one has the higher priority? Aldehyde. So you identify this as aldehyde. Hurry. Once you identify this as aldehyde, this is your functional group. This is the functional group for aldehyde part. All right. Then identify step 2, main carbon chain. You know how to identify main carbon chain. First of all, we go to functional group. Fortunately, that carbon is one corner, one end. So you can start from that carbon, come to the junction. Once you come to junction, what do we do? 2 options, left or right. Once you have left or right option, then we have the second priority, double or triple. Yes, double available. Then this is your main carbon chain. Right? This is your main carbon chain. CHO is the functional group. In that case, once you identify the main carbon chain, you can identify these things as what? Substituent. This whole group is substituent. I told you, it's not hydrogen, it's not functional group. Then the whole group should be attached to main carbon chain. It should be a substituent. Br is also substituent here because functional group CHO, it can't be now substituent. Sorry, it can't be functional group. So it's substituent. Hurry. This is the case. Thereafter, we go to number in part. Number in functional group should have minimum possible number. Then it's very clear. If you start from this end, the number will be 1, 2, 3, 4. That's the correct one, because if you go back here, 1, 2, 3, 4. Then for the functional group, there are 2 options available. What are the 2 options available? Number 1 or number 4. Then out of 1 and 4, which one is the minimum number? Out of 1 and 4, the minimum number is 1. Therefore, definitely, here the green one is correct, red one is wrong. Right. Look at this compound. CH3CH, 2COH, H, CH double CH2. If you get a structure like this, go to the first step. Go to the first step. What is first step? Identify the class, then alkane, alcohol, alkene. Which one is that? Alkane, alkene, alcohol, then high priority high, alcohol. So we identify this as an alcohol. If that is the alcohol, the functional group, functional group should be OH. If the class is alcohol, functional group is OH. Hurry. Go to the step 2, main carbon chain. This is the only carbon chain available. I told you, remember, I can't start from the middle. I should start from this end to this end. So this is your main carbon chain. That's the main carbon chain. It's just one option available. That is the main carbon chain. Easy, right? Now, number in main carbon chain. Number in main carbon chain. So now you are going to put or assign number for each and every carbon atom. So look at this one. If I start from this end, this carbon will be number 1, this carbon number 2, number 3, number 4, number 5. Then first in functional group, then functional group has number 3 if it is green. But one can start from the other end. Number 1, red, number 1, number 2, number 3, number 4, number 5. Look at this. Look at this one. For the functional group, you have again number 3. If it is green one correct, number 3 goes to the functional group. If it is red one correct, number 3 again goes to the functional group. Then which one is correct? Same number. Once you get same number to the functional group, then go to the next one. What is next condition? If there is CC double bond or CC triple bond, if there is CC double bond or CC triple bond, that should have the minimum possible number. Double bond or triple bond should have minimum possible number. Then look at this. If it is green one, green numbering, I hope you can see the colors. Yes, you can see. But the thing is, this one, I write the red one here. 1, 2, 3, 4, 5. Sorry. If it is green one, number 3 to the functional group. If it is red one, number 3 to the functional group. That's not important. Then we go to the next priority, double and triple. Look at this. If it is green one, number 4 carbon starts double bond. Then double bond between 4 and 5. Don't consider both of these, to just consider carbon which starts double or triple. Hurry. 4, number 4. But if it is a red one, you see number 1 carbon starts double bond. Therefore, in this case, for the double bond, either number 1 or number 4. And then it should be the minimum possible number. Then out of 1 and 4, which one is minimum one? Definitely 1. It is number 1. Because of that, you can say green one wrong, red one is correct. Green one wrong, red one is correct. Got it? Sometime double triple not available. Assume this doesn't have double bond. CH2, CH3, no double bond. Then I forget again red and green part. But still, main carbon chain is this one. Double triple not available. But I see a bromine atom on this carbon. This carbon bromine atom available. You can't see it. Bromine atom available on this carbon. Now you know, once you identify OH, the functional group, Br is identified as a substituent. I think you can understand the difference between functional group and substituent. I explain it. Here OH has high priority, then it is identified as a functional group. Br then should be a substituent because it is attached to main carbon chain. It's not hydrogen. It's not functional group. Sorry, it's an alcohol. Okay, this is the story. Now the numbering part. We identify the class, we identify the main carbon chain, then numbering. Numbering, these are the possibility: number 1, number 2, number 3, number 4, number 5. But one can say, no, it should be other in. All right. 1, 2, 3, 4, 5. All right. You see the situation? I hope you can see it. Now, functional group OH has same number 3, 3. It's not important. Then we go to double triple, but double triple not available. We have problem. All right. Then go to the next priority. Substituent should have the minimum possible number. Same order I gave you under step 2 also. Functional group, double triple, and substituent. Here also functional group, double triple, substituent. Easy to remember. At the beginning, maybe it's quite difficult, but once you do several examples like this, it's nothing. Sorry. Then substituent should have minimum possible number. Then we identify here substituent BR. Once you identify substituent BR, there are two numbers. What are the numbers? Number 2, number 4. Number 2, number 4. Then which one is suitable? Minimum possible number. Then out of 2 and 4, which one is minimum? 2. Therefore, here green one correct, red one wrong. That is how we number these compounds. This is the main part in nomenclature. If you can do these 3 steps, most probably you can quickly find out the answer in the MCQs. This is given as MCQ. So once you have this idea, you can just go through the answers, 5 answers given. Quickly you can identify the correct answer. No need to name it fully. But main thing is following these 3 steps correctly. That's why I explain it in detail and very slowly. But next week we can be fast. Right. Let's try the note for step 3 then. Write step 3. We have to complete the note also. Write step 3. Step 3, write it like this. Number main carbon chain. First step, identify the class. Second, identify the main carbon chain. Step 3, number main carbon chain. Under that, we write down. Under that, write down. In this step, each and every carbon atoms in main carbon chain, in this step, each and every carbon atoms in main carbon chain is assigned with a certain number. Is assigned with certain number. Will this be available in the channel? Yes. This will be available. Therefore, you can get the note by referring it. Right? In this case, each and every carbon atom in the main carbon chain is assigned with the certain number. Then start new point. Numbering can start from either end. Numbering can start from either end. Numbering can start from either end. The following requirements are considered. The following requirements are considered. The following requirements are considered to identify the correct end, the numbering should be started. Under that, write the first one. There are three. Write the first one. Minimum possible number should be given to the functional group. Minimum possible number should be given to the functional group. Second thing, CC double bond or CC triple bond. CC double bond or CC triple bond. Again, write with within bracket, write if available. If available, close bracket. CC double bond or CC triple bond should have the minimum possible number or should take the minimum possible number. CC double bond or CC triple bond should take the minimum possible number. Right. Last one. The substituent should take the minimum possible number or lowest possible number. Minimum or actually lowest, that's more suitable. Substituent should take the lowest possible number. Right. Nomenclature, then in the case of nomenclature topic, I mainly explain the first three steps. Those are the most important steps. If you are good in these three steps, then nomenclature, nothing. One more step available, step 4, is just naming the compound. But naming compound is done by taking the compound separately. Like I take alkane and explain it. Then I take alkene and explain it. Then I take alkyne and explain it. So likewise, we take different compounds and explain the rules. So definitely then next week, three more hours, yes. I'll do one more extra class like this to complete the nomenclature part. So next week, definitely we can finish the nomenclature part. But I think you have the note. In that note, you see some exercises available. In the note, how many? I hope all of you collect the note. It is there in the description, Hari. You see question number 2. Question number 2, identify the main carbon chain and number them correctly. Therefore, now I'm not going to do it. In page number 7 at the bottom, you have the question number 2 in the note. There are 8 compounds given. That is to identify the class, first 3 steps. Identify the main carbon chain and number it correctly. This is the homework. All of you should do this homework before next week class, because next week class, I will start from that point. I'll take these things and explain those things. Then I will continue the class. And definitely next week class, I will finish the nomenclature part. Understand? Right. Then thank you very much. Still you stay in the class. Good. Then I need that support next week class also. So next week class, we will finish nomenclature part. Right. I think that's enough. Okay. See you next week then. Good night.